Everyone. Happy Monday. I hope you had a good weekend. We only have 5 days and then we get out for spring break, which is crazy. Some reminders. Remember that the grading period ends this Friday. So that's your 9 weeks grade. So your attendance check-in today is to check skyward. Make sure you've got everything that you need turned in or corrected. Work on those. You have until Friday at 3:30 to get any grades or any assignments turned in. I'll take them until Friday at 3:30, but after that, I won't take them. Okay, so the plan for today is we're going to still be talking about quadratics. We're still in Unit 8, and we are going to have a test this week. We'll have our test probably on Thursday before we get out for spring break. So on the modules page, we're going to be talking about applications of quadratics, which just means how they apply in real life. So you do have one assignment to do after this video. And then in the video, I'm using the notes that, remember, are all coming from the journal slides right up here that I posted at the beginning of Unit 8. So let me bring up my notes here. Now, we are skipping around a little bit because if you're looking in your notes, Lesson 4 is supposed to come first, transformations, but I've kind of moved some things around to fit our schedule better before we get out for spring break. So we're going to move on and talk about applications. After spring break, we'll come back and do that Lesson 4, and then we'll take like a little quiz over it. So this is called happiness versus the cheeseburger. Okay, so you have a friend and he can eat a lot, or she can. Maybe it's a she. No, it's a he. It says cheeseburgers are his favorite, so he gets happy when he eats them until he has too many. If you measured his happiness, and they're calling his happiness h of x, that's function notation. That's another name for y. Remember that. Is based on how many cheeseburgers he eats, x. So that's important. So how many cheeseburgers he eats is x, and his happiness is h of x. You'd get a curve that looked like this. So they're giving us the equation for the curve. So it's wanting us to graph it over here. Don't forget to label your axis. Well, they told me that x is the number of cheeseburgers. So that's down here, right? So the number of cheeseburgers that he eats, it's going to go here on x. And then the y, they said, is h of x, and that's his happiness. So his happiness level is here. And again, that's h of x. And this one is x. Okay, so let's label it. But in order to do that, label it. Let's graph it. Let's use Desmos, because Desmos is always nice to use. Whoops. I didn't mean to do that. I'm trying to move this over. Okay, so I'm going to go over to Desmos. So our curve was h of x equals negative x squared plus 6x plus 16. So there's my graph right here. So I'm going to zoom out so I can see the whole picture here. Okay, I've got it right here. And notice on our notes here, the graph they gave us, they didn't give us all 4 quadrants. They just gave us the first quadrant. So they just want us to graph the piece that's in here, which happens a lot when you're talking about applications, because it doesn't always make sense to talk about negative time. We don't talk about negative time. It doesn't always make sense. It would not make sense to talk about negative cheeseburgers. So we only need positive cheeseburgers. So we're going to graph this part here. So let's click. So if we're going to start and only graph this quadrant, well, here's some pieces here that I'm going to need. So I need to go all the way up here to about 25 on my graph. And then I need to go over to, I need at least 10 spaces. So I'm going to graph this. I'm pretty sure I can count by ones on my x-axis, but I think let's count by maybe, I don't know. We could count by 2s probably on our happiness. So if we start here and we do 2, and then this will be 4, okay? We're going to count by 1s here. So I'm going to graph these points over here. Let me move this over so we can see. Y'all, I keep doing this. I don't know what my problem is. Let me pull this out. Should have done this before. So I can go side by side for you guys. Let me get my thing back. Oh, my computer is doing some crazy stuff right now. Interesting. Okay, so I'm going to, let me click these points again. Here's all these points. And I don't need this one because it's negative. Remember, I only want to stay here. So I need to go up to 16. So that would be 2, 4, 6, 8, 10, 12, 14. So we'll about there. So at 0, 16, I need a point there. And I need a point over here at 325. So this is 1, 2, 3. So I need to go up to 25. Well, if that's 16, then I need to go up to 18, 20, 22, 24. That would be 26. So about right there. That's a rough estimate graph. And then over to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And there's a dot right there on the axis. So I'm just going to try to connect it here. Okay, so there's our graph, a rough sketch of the graph, just that first quadrant. Okay, it says if your friend wants to be as happy as possible, how many cheeseburgers should he eat? So when you're looking at these applications of any function, actually, you need to pay attention to what your axes are labeled. So we have happiness on the Y and number of cheeseburgers on X. They want to know how many cheeseburgers. So they're asking me for an X value. And they're saying his happiness needs to be as high as possible. We want to be as happy as possible. Well, his maximum happiness is going to be, because this is Y, as high as it goes is up here, right? At this point right here at the top, 325. So if X is cheeseburgers, well, if he eats 3 cheeseburgers, then Y measures his happiness. His happiness never goes above 25 because there's nothing up here past this point. This is the maximum point. So how many cheeseburgers should he eat? Well, he needs to eat 3 cheeseburgers. How do you know? Because that's where the maximum happiness. You could just put that's the maximum value for happiness is at X equals 3. Ooh, my thing's going slow again. So the maximum value for his happiness is when he eats 3 cheeseburgers. What does the y-intercept of this graph represent? Okay, so they're talking about the y-axis here. Here's my y-intercept. So again, I'm going to look at my labels here. X value is cheeseburgers. So how many cheeseburgers has he eaten here? 0. And the y value measures his happiness. What's his happiness? 16. So it's saying before he eats any cheeseburgers, he's still pretty happy. Because he has a happiness of 16, whatever that measures. You know, this is a silly example. Sometimes those are fun. So his happiness level is 16, I guess, if he's rating it from 0 to 25. He's about 16 before he's eaten. Okay, it says number 4, how many cheeseburgers can your friend eat before he becomes unhappy? Okay, so here his happiness level is 16. And if we trace this, look, the y value is going up, right? His happiness. Then he eats 3 cheeseburgers and he's real happy. He's at 25. But then if I'm tracing this line over here, let me click on this. Notice how his happiness, the y value, the x value is still going up because now we're almost to 6 for our x value. But my y value is 16. So his happiness he's not as happy as he was because he's eating 6 cheeseburgers. And then down here, we keep going. Oh my gosh, he's eating 7 cheeseburgers. Now he's approaching down here. See, his happiness is real low. He's at a happiness level of 1. That's lower than before he even started eating cheeseburgers. And right here, well, my x value is 8. That's number of cheeseburgers, remember? I told you the labels are so important. He's eaten 8 cheeseburgers, and his happiness level is 0. He has no happiness at this point. Well, how many can he eat before he becomes unhappy? Well, if he eats any more, even a bite after he eats 8 cheeseburgers, look, he's in the negative happiness level here. So he can only eat 8. Then he's going to be real unhappy. Because think about it. If you ate 8 cheeseburgers, would you be feeling great and feeling happy? I don't think so. Calculate your friend's level of happiness if he ate 10 cheeseburgers. What does this mean? Well, there's 2 ways to do this. So remember, X is the number of cheeseburgers. So we could try to trace this curve and try to get to 10, but sometimes it's really hard to get right on 10 in Desmos and do that. So there's another, see, I'm going 9.96 and I try to go to 10 and it jumps, but it's somewhere in there. But if I come over here on the side and I say, okay, what's my happiness if X, my number of cheeseburgers is 10, All I need to do is plug in 10 here. Remember, Desmos does that for us. So his happiness, when my input is X, number of cheeseburgers, my input is 10 for my number of cheeseburgers is negative 24. So in order to do this, you have to make sure that you have function notation here, that you have the H parentheses X. And so then you can come down to the next line and just put H and say, hey, Desmos, plug in 10 for that X there. We've done this before. This is evaluating functions. So his happiness, if he eats 10 cheeseburgers, is negative 24. What does this mean? He's unhappy. He's very unhappy. He's probably throwing up. He's probably sick, honestly. That's what I would say. Okay, so really, the key to these type of application problems is pay attention to your labels on your axis. They're going to tell you what X represents, and they're going to tell you what Y represents. You're going to use Desmos to graph these and then interpret it from there, okay? So I want you to try your hand at these. If you have some questions, I want you to go ahead and try the next one too, the Hail Mary pass. It's a similar problem. They're giving you an equation. You can type it in Desmos, read the little scenario, and then there's actually like a link down here. You can watch the video at the end to see if this team actually just completed the pass. So that's kind of interesting. See if it worked for the Huskies. So answer these questions. Similar thing. Pay attention. What is your X representing, and what is H representing for this one? They tell you in the problem. Okay. They're telling you that the ball's height is H being measured over time. So T in place of X for this one is going to be time. So your X axis is representing time. So try your hand at this one. And then there's the assignment that I posted in Canvas is just 6 problems, but very similar. So again, you're going to be utilizing Desmos, and I put use Desmos to answer these questions, okay? So then you can click that and it'll open it in a new tab for you. Get it Desmos open. But then the height of a tennis ball is measured here. See, they're telling you that X is your seconds, and here's your function right here. Okay, so see if you can complete these problems.